Hello everyone. So now we move on to topics of natural language processing, NLP, and large language model, LLM, very popular topics in this days. This lecture will cover two main parts. The first part is on natural language processing. We'll provide a brief overview. And then the second part, we will talk about large language model and how come it can work for text generation. Natural language processing, probably you have heard about it very often these days. So it's actually talking about analyzing, understanding, and also defining meaning from human language. We can communicate very well among ourselves using natural language, but then, well, how about the machine? We want the computer can also do it. Application actually go more than just chat. It can include machine translation. They translate the text to another language. We can do the text summarization. Even a very long document, you want to have a concise and precise summary. And then the sentiment analysis. Given a sentence, we want to know that whether it is positive or negative. For example, for customer review, we want to know whether the customer liked the products or not. Then we look at the words, whether it is positive or negative. Then that's sentiment analysis. And then we have question answering. And for sure, we have chatbots. It is very popular. Let's zoom in a bit more on chatbots. So we are using it almost every day. At least for me, it's like that. First, we type in some sentence, then you will be used as the input sentence, and then the computer will understand it and give us the response. So what's happening inside the chatbots? Basically, there are two main stages you can see here. The first one, the machine tries to understand the sentence in natural language. So we call it natural language understanding. Without understanding, of course, we cannot respond. So that's why the chatbots will try to understand it. They try to turn the language into some internal formats that only the computer can understand. Afterward, then you will move to second stage. We call it the natural language generations. So based on this internal format, then they try to generate response. And so what's happened inside this two stage? Later, we will talk about the detail. But first of all, let's take a look at the development of chatbots. You probably recall it in last week, we learned this Turing test. There's a term called Turing test. So that's basically the idea of chatbots. So we have someone chat with the computer system, and then well, if you cannot distinguish whether it is the computer or the real person, then we say that computer system passed the Turing test. It worked very well. Even the human cannot distinguish it. Then this idea, so basically that's chatbots. People chat with the computer system. So this idea is not so new. Back to 1964, a very early stage of AI development, there's a chatbot called Elisa. Left-hand side. So this is more developed by some people in MIT, and they try to emulate Rogerian's psychotherapies. What does it mean? It means that they don't have the general knowledge, but then they try to grab some keywords and something from the question that you ask, then try to get response. Try to respond to your questions without any general knowledge. For example, you can see the conversation here. You start with Elisa. Hello, I am Elisa. and that try to grade the user. And then the user say, okay, I feel sad. Then we take a look at the response from Elisa. Elisa say that, okay, tell me more about such feeling. So you will see that it is quite general. Okay. And then, but it also show that Elisa is trying to engaging with the user. And we have the user saying that I do not want to eat in these days. And then again, Elisa tried to give a very general response. What does that suggest to you? Okay, you will say that, well, Elisa is trying to respond, but then, well, there's nothing in there. You just keep the conversation moving, right? So that's Elisa. And then we have Alice, okay, 1995, we have Alice by another group of people in the Lehigh University. Again, it is chatbot, but this time with general knowledge. They're trying to answer the questions with general knowledge. We can follow the conversation here, but then we just go all the way to the bottom to this line. John, which is the user, asks a question, what is sun? And then Alice is able to answer that, saying that the sun is the star for our own solar system. Okay, you will see that we don't have this knowledge of sun in the previous conversation, but then Alice is able to answer this question. It means Alice with a general system. So you have the knowledge base and that yeah, Alice. And we will see that that's the trend. And nowadays we're using ChatGPT, and you know very well that it contains a lot of knowledge such that it can answer our question. So now we have some idea about the development of chatbots, and next we try to zoom in at what's happening for large language understanding. Basically, there are four steps behind. The first one we call it the lexical analysis, and then we have syntactic analysis, semantic analysis, and thematic analysis. Let's take a look at them one by one. We start with lexical analysis. Sometimes we will call it tokenization. First, we have a article, okay? And then lexical analysis will divide it into paragraph, and then to sentence, and then divide it to words, or we say tokens. And then that's lexical analysis. For English, then that's pretty more straightforward. We just look at the space, the full stop, then we can do it, right? But for some language, it may not be that trivial, like Chinese. Spacing is not very often. Sometimes the characters go one by one, then that will be more difficult. There's some potential difficulty for different language, but yeah, lexical analysis is doing this kind of task. And then we have syntactic analysis. So to learn a new language, of course, we need to learn the grammar. Syntactic analysis is trying to convert a sentence into a structural description with the grammar root. We can take a look at this example. John hits the ball, a very simple sentence. And then we know that, okay, John is the subject, and then hits is the verb, and to what? Okay, to the ball, and ball is actually the objects. Then you can try this link to get more example. And more than that, okay, you will try to do some more stuff, like for that hits. So for hits, we have different form, but with the same meaning. For example, hits and hit with as and without as, they carry the same meaning, right? So we try to eliminate the prefix and affix so that the computer know it refers to the same meaning. We call it stemming. And sometimes we can have this another way to do it. So limitations. So here we say that we try to convert the those words into another format, the canonical form. For example, better, okay, we change it to good. Okay, good, just keep it as good because they're carrying the same meaning. So by doing this, the computer know, okay, they are talking about the same thing. And that's the syntactic analysis. The step 3 is the semantic analysis. So we are able to know whether the sentence itself is meaningful or not. Again, we take a look at the example. So here we have kindness hit the ball. We replace John by kindness. If we look at the sentence, it is grammatical correct. But then kindness is an abstract concept. It's likely it cannot perform the action of hit. And so semantic analysis is able to identify this kind of semantic order and then tell you, well, this sentence is not meaningful. Step 4 will be our pragmatic analysis. Sometimes we have to get the meaning, not just from that sentence, but then the sentence before and behind the sentence. Just for example, okay, again, we take a look at the example. Now from an article, we have a sentence say, John likes apple. Okay, John likes apple. And then in case that article is about computer store, then we know that Apple probably means computer, okay? But then if the article is about a supermarket, then the apple should refer to the fruits, right? So sometimes we need to look at the whole article to get the exact meaning, and that's the pragmatic analysis. And no matter what technology you are using, we need to perform this 4 step to understand the meaning behind the sentence in natural language. And after this 4 step, then we will have an internal format that describing the sentence that the computer can understand, and then it can use this internal form to generate the response. And the generations, there are 2 approaches. The first one, okay, pretty simple, straightforward. Unfortunately, the current technology is no longer using it, and later you will know why. Okay, but it is easy to, it is good to understand. We call it the rule-based method. And the second method, which is the second part of this lecture, LLM. We start with rule-based method. If you have a lot of concept of keywords and you can create a lot of response campaigns, then rule-based method will be pretty well. Well, how does it work? We also call it the method behind this, we call it the pattern matching. Take a look at this example. For example, we have first we create concept of interest using keywords. For example, manufacturer is the concept of interest, and then keyword is Apple, Lenovo, Samsung. You will see that we use brackets for this manufacturer, means that it is a concept. And then based on this concept, we create response campaigns. For example, manufacturer computer is great. Which model do you like? Well, this is a very typical response from the seller, right? So when they try to sell you the computer, they will say, okay, this is great. Okay, which model do you like? But we do not want to repeat it for many, many times. We have this concept here. Then let's take a look at how does it work. basically we try to match the keywords in the input and then substitute it into the campaign. For example, in the input, we have this, I like apple, right? So we check, okay, we try to match it to the keywords. So whether we have some keyword in this input, we find that we have, okay, the apple is one of the keywords of the concept manufacturer. Then we will replace this apple with this manufacturer, the brackets here, and we get the output. Apple computer is great. Which model do you like? For another example, I am considering Lenovo. Again, we will find that, oh, Lenovo is one of the keyword. And so we substitute it into the campaign. We paste this word and we find, okay, Lenovo computer is great. Which model do you like? And so this is how the rule-based method works. If you can create a lot of concept, a lot of response campaign, then we can show people we can respond to that pressure very well. Rule-based method is kind of expert system. To record, we talk about it, the expert system, the booms of AI in week 1, right? So when we talk about AI system, expert system is basically referred to the second rule. Expert system design the many rules and hope that this rule is rich enough for the AI to give good decisions, give good suggestions. The advantage is the rules. Okay, if we do so, it is quite easy to understand. Okay, we can interpret the meaning. We call it interpretable. And hence, you can design the rules, you can update the rule easily. But the disadvantage is that we will need many rules so that the AI is able to work like human, but it is not that possible for us to design so many rules to cover all the situations. And that's why at that time, expert system does not work and turn out to the winter. Until, okay, we have ChatGPT, okay, that changed the game of NLP. Then we can move forward. And now we move forward, okay, to the second way, okay, LLM, and how it can generate the task. So nowadays we were all very lucky. Okay, student and staff are all lucky because we can go to the HKBU Gen AI platform to enjoy all the AI model provided by the university. You can see GPT, you can have Gemini, you have Llama, DeepSeek, right? And even you can generate image, which we will cover next week. You may know the terms transformer, GPT, ChatGPT, LLM. In this slide, we would like to talk about the relationship amongst those terms. First, transformer. Okay, transformer in 2017, okay, by the Google. Okay, it is originally applied to machine translations. And then we have a very special format of transformer. We call it the GPT. The full name is Generative Pre-trained Transformer, and that's by OpenAI. So it is a special type of transformer that can generate tests, okay, given a prompt. And then the practical difference is like the transformer is built for the task like translation. They input one sentence in one language, we output the sentence in another language. So while GPT is designed for text generation from a prompt. People want to use it to answer questions which lead to the ChatGPT. So this is a fine-tune with data and also reinforcement learning. Okay, last week we learned it. Okay, reinforcement learning. ChatGPT use it, okay, for training, and it can give a very high quality answer to in natural language. We skip the detail P. But from beyond ChatGPT, we have Gemini, we have Llama, we have copilots by some other company. And last, this large language model, LLM, is umbrella terms of all this model. So hope that this give you some background on the relationship amongst those terms. Okay, I want to briefly touch on some very simple mathematics so that you have a more idea what's going on behind this large language model. And then here the heading LLM generate tests using conditional probability. What does it mean? Let's say give it a test. Okay, now we call it prompts. I wish to. The LLM will try to estimate the next word, next most probable word. How to do it? By comparing the conditional probabilities. Again, if you input I wish to, what the LLM will do, it will try to find out the conditional probability of all the combinations. Okay, the probability of having no, if we input I wish to, the probability of having learned, okay, if the input is I wish to, it try to get all the probability, do the ranking, and then responds you with the highest. Then that is how it find out the next word. Okay, we have the next word. Then how come we can have the whole sentence or paragraph? Here show you the stuff. First, I have I wish to, and then by calculating, considering the conditional probability, we find that no is the best response. And so we have I wish to know. Okay, you see the no on the screen. And I wish to know will be also be used as the input of the next iterations. So this time the input is I wish to know. And again, we will calculate the conditional probabilities of all the combinations. And then let's say we find that that is the most appropriate response. That means with the highest conditional probabilities. And then we will have the that. And after I wish to, and then you saw that on the screen. And that's the reason why if you're using the chatbot, you will see that the response is appearing word by word because they are working on that. They are calculating the probability and then find out the most suitable one. Okay, so that's how we have the whole sentence. But then, well, just do the ranking is pretty straightforward. But you may also notice that, well, there are many combinations, right? So it is very hard to calculate all the combinations. And don't forget that we also have syntactic, semantic, pragmatic analysis. So this is a very, very challenging problems. And the magic and why we can make it worse, that's to transformer. Okay, the magic behind LLM is transformer. Let me remind you again, this is deep learning models. So we are not going to learn the detail, but at least we know that a transformer is the magic behind LLM. So this is the core technology. This transformer, it can carry out the syntactic, semantic, pragmatic analysis of NLU, and also able to estimate the conditional probability efficiently. Okay, and then do we need to write a program to do this? The answer is no. Okay, it used machine learning that's we learned before, and it will just require a lot of data because you want to involve all the combination, right? So you need a lot of data, and that's why you call LLM. And so it will train the model, and then the model can understand what you say and generate the response. Then that's the magic of LLM. To summarize, okay, finally we go to the end. We come to the end. To summarize this lecture, we have touched on the natural language processing, and there are two steps. Okay, natural language understanding, natural language generations, and there are several steps involved. And the magic that make the LLM so powerful in this day is transformer, which is a deep learning model. Okay, thank you. Bye bye.